Hi, welcome to Math with Miss B. This is your demo video that everybody needs to watch before class on Wednesday so we know how to use algebra tiles in class. So the two learning goals we're going to cover today are 1, learning how to model quadratic equations using algebra tiles, and 2, defining quadratic equations. Alright, so let's go ahead and talk about the history of quadratic equations. So in 1820 CE, Al-Khwarizmi was a Muslim mathematician, and in his name it's not pronounced Khwarizmi, it is Khwarizmi, but he is the founder of algorithms and algebra. But back in his time, it was not called algebra, instead it was called Al-Jabr. So he focused on combining these two subjects, and he created this method called completing the square, which we are going to learn on class on Wednesday. So he used terms to describe completing the square as squares, roots, and numbers. Now, if we were to translate these to terms that we know today, a square is frequently represented as x squared, and a root would be x, and a number could just be any sort of number that we know, so let's just go ahead and write 1. Now when we complete the square, we need to combine all these squares, roots, and numbers into a formula. So what he wrote was x squared plus x plus 1. Now, we know that that's just one simple equation, but we need to generalize it for all quadratics. So instead, what we are going to do is write a, b, and c next to each of these terms to generalize it, where a, b, and c are just any real number that we can think of. So it could be 2, it could be 3, any sort of number that we know. But we know with this last term, if we have 1 times c, it's the same thing as just saying c. So a times x squared plus bx plus c is going to be our general form for quadratic equations. All right, so we just talked about the general form of the quadratic equation, which is ax squared plus bx plus c. Now we can use algebra tiles to take a visual geometric approach to solving algebra problems. So there are 3 types of tiles. The first one that we have is x squared. So the nice thing about x squared is that we can take our other algebra tiles of just x and use them to represent our side length. So we know when we find the area of this, x times x is going to be x squared. So this helps us understand then the second piece. So this is x, and our last piece is going to be these little figures over here, which are 1. So let's go ahead and look at an example. If I have x squared plus 4x plus 4, in this case, this would mean that a is going to be 1, b is going to be 4, and c is also going to be 4. So when I model this, we want to make a square out of these tiles. So the first piece we're going to use is, since we have 1x squared, I'm going to use one of my blue x squared pieces. Next, I have 4x, and when we make a square out of this figure, we're actually going to only divide by 2 for 4, and we want to put 2 of our x figures here on the side next to our big square. And then I want to put the other 2 below x squared. But this still adds up to, there are 4 of these x's. And then lastly, we know that c is equal to 4, so I want to put 4 tiny little 1 pieces down here in the corner. And we can see that when we put them all together, this makes a giant square. So now, if I specifically look at the side lengths, I see that I have one side length up here and another side length down here. And the way that we can label these side lengths is by writing this as x plus 2 and x plus 2. So since we want to find the area of this whole thing to help us then complete the square, what we would write this as is x plus 2 times x plus 2. And another way to write this is as x plus 2 squared. So when we complete the square, we want things in this form. So completing the square using these visual algebra tiles is a good way to get us started. All right, so for this last example, we're gonna take a different approach for this one. So here I already set up my figure, and from our model, we want to go ahead and create an equation from this. So similar to what we did before, I know that there is one x squared piece, And all I want to do now is count how many pieces I have for this x term then. So we have 1, 2, 3, 4, 5, 6. So I'm going to write that as 6x. And lastly, in order to get this last piece of our quadratic expression, we have 9 of these 1 pieces. And we can see that this aligns with our quadratic form of ax squared plus bx plus c. So for homework, what I want you all to do is to make your own square and write an equation and bring it to class on Wednesday. All right, so let's go ahead and preface class on Wednesday. So by now we've seen examples where a figure is a perfect square, but what happens now if there are too many or too few algebra tiles? So let's look at this example. So if we have x squared plus 4x plus 3, let's use the skills that we've learned now to model this. So I know that there's going to be one x figure, 2 x tiles on the side, and 2 x figures below. But by our equation, we know that there is going to be only 3 of these little tiles. So we have 1, 2, and 3. So the issue with this one is that I'm missing this one little piece down here to make this a square. So your task for homework is to think of one way to solve this problem we've encountered now and write it down to bring to class. And on Wednesday, we're going to learn how to solve these types of problems using algebra tiles and completing the square.